what a day to be on the internet. Go 124 came out today, and I want to go through the release notes. I have been doing a lot of Zig stuff on this channel. I write a lot of Go professionally. I still really love Go. I think it's probably still my language of choice. Zig solves a couple of my Go problems, but I'm hoping that 1.24 might push us in the right direction to solve those in Go. So let's take a look at it. So this is the Go 124 release notes. Here's a table of contents, just some highlights of what we're looking at. It's introduction, changes to the language, new tools or tool changes, information about the runtime, the compiler, the linker, the bootstrap, the standard library, improved finalizers, the new weak package, crypto mlkem package. I know nothing about this. hkdf, pbkdf2, and SHA-3 packages. Cool. FIPS 1403 compliance, no idea about that. New experimental testing synctest package, minor changes to the library. Ports, Linux, Darwin, WebAssembly, Windows. Let's get into it. The latest Go release, version 124, arrives 6 months after Go 1.23. Most of the changes are in the implementation of the toolchain, runtime, and libraries. As always, release maintains the Go 1 promise of compatibility. We expect almost all Go programs to continue to compile and run as before. Excellent. 124 now fully supports generic type aliases. A type alias may be parameterized like a defined type. See the language spec for details. Let's do that. Alias declarations. An alias declaration binds an identifier to the given type. So alias declaration, identifier type. Oh, yeah, okay, sure. So type aliases. With generics, I guess. For now, the feature can be disabled by setting Go experiment no alias type params, but the alias type param setting will be removed for Go 125. So it is coming whether you like it or not. Tools, the Go command. Go modules can now track executable dependencies using tool directives in Go mod. This is really, really nice. This removes the need for the previous workaround of adding tools as blank imports to a file conventionally named tools.go. That seems like such an anti-pattern. The Go tool command can now run these tools in addition to tools shipped with the Go distribution. For more information, see the documentation. Let's pull it up. Tool dependencies let you manage developer tools that are written in Go and used when working on your module. For example, you might use stringer with Go generate. Sure. So in Go 124 and above, you can use this, go get tool. We'll add a tool directive. Once this directive is added, you can run the tool by passing the last non-major version component of the tool's import path to Go tool. Okay, so in the case of stringer, you just pass stringer. In the case that multiple tools share the last path fragment, you can use the full, or you must use the full package instead. Okay, Go tool shows you all the tools. Go mod tidy can help clean up those tools. What else? The tool meta pattern refers to all tools in the current module. Executables created by Go run and the new behavior of Go tool are now cached in the Go build cache. Repeated executions faster at the expense of making the cache larger. Yeah, space is cheap. The Go build and Go install commands now accept a -json flag that reports build output and failures as structured JSON output on standard out. That is really, really nice. Scrape that up, throw that into your log processor, and parse away. Furthermore, Go test -json now reports build output and failures in JSON interleaved with test result JSONs. Okay, heck yeah. The new GOAUTH environment variable provides a flexible way to authenticate private module fetches. That sounds really helpful. The Go build command now sets the main module's version. Okay, cool. Cgo supports new annotations for C functions to improve runtime performance. Cgo no escape C function name tells the compiler that memory passed to the C function does not escape. Nice. Cgo currently refuses to compile calls to a C function which has multiple incompatible declarations. For instance, if f is declared as both void fint and void fdouble, Cgo will report an error instead of possibly generating an incorrect call sequence. Yes, that's so much better. Error early. Don't let me make an incorrect call sequence. New in this release is a better detector for this error condition with the incompatible declarations that appear in different files. Awesome. The object dump tool now supports disassembly on 64-bit long arc, RISC-V, and S390X. Cool. GoVet. The new tests analyzer reports common mistakes in declarations of tests, fuzzers, benchmarks, and examples in test packages such as malformed names, incorrect signatures, and examples that document non-existent identifiers. Some of these mistakes may cause tests not to run. This analyzer is among the subset of analyzers that are run by GoTest. So this is going to be running on GoTest for you now. The existing printf analyzer now reports a diagnostic for calls, okay, where S is a non-constant format string with no other arguments. Such calls are nearly always a mistake as the value of S may contain the percent symbol. Use fumped print instead. Okay, cool. Build tag analyzer, copy lock analyzer. So some analyzer improvements that are pretty exciting. Go cache prog, the command go internal binary and testing caching mechanism can now be implemented via child processes implementing a JSON protocol between the command go tool and the child process named go cache prog environment variable. I don't know what this is, and it doesn't sound super relevant for me. Runtime. Several performance improvements to the runtime have decreased CPU overheads by 2 to 3%. That's pretty big, actually. I'm pretty excited for that. On average, across a suite of representative benchmarks. Results may vary by application. Sure, consult your doctor before trying Go 1.24. These improvements include the new built-in map implementation based on Swiss tables, more efficient memory allocation of small objects, and the new runtime internal mutex implementation. What are Swiss tables? Family of hash tables in place of standard unordered set and standard unordered map. Swiss tables hold densely packed array of metadata containing presence information for entries in the table. This presence information allows us to optimize both lookup and insertion operations. The metadata adds 1 byte of overhead for every entry in the table. So in addition to your standard table, or your stable map, I guess, it adds extra metadata that helps with optimizations. Okay, tons of information here. I am not going to go into this all right now, but this might be a fun thing to dig into in another video. The new built-in map implementation may be disabled if you want to disable it. The compiler already disallowed defining new methods with receiver types that were Cgo generated, but it was possible to circumvent that restriction via an alias type. Now you always get an error. The linker now generates a GNU build ID, the ELF NTGNU build ID note on ELF platforms, and a UUID on Mac OS by default. The build ID or UUID is derived from the Go build ID. It can be disabled with a flag. Bootstrap, as mentioned in the Go 122 release, Go 1.24 now requires 1.22.6 or later for Bootstrap. We expect that Go 126 will require a point release of Go 124 later for Bootstrap. Does this just mean to install Go 124, I need Go 122 installed? I'm not too positive. Let's see if that information is captured here. I could keep following bootstraps all the way down. When building a Go release from source. Okay, that makes sense. So only if building from source. That is fine. That's not very relevant for me. I've not needed to do that, and hopefully most people don't either. Standard library. Directory limited file system access. The new os.Root type provides the ability to perform file system operations within a specific directory. os.openRoot function opens a directory and returns an os.Root. Methods on os.Root operate within the directory and do not permit paths that refer to locations outside the directory, including ones that follow symlinks. That's really nice. Keep things safe and secure. Don't let people crawl all over your file system. The methods on os.Root mirror most of the file system operations available in the OS package, including open, create, makedir, and stat. Benchmarks may now use the faster and less error-prone testing.b.loop method to perform benchmark iterations like b.loop in place of the typical loop structures involving b.in or for range b.n. This offers 2 significant advantages. The benchmark function will execute exactly once per count, so extensive setup and cleanup steps execute only once. Function call parameters and results are kept alive, preventing the compiler from fully optimizing away the loop body. That is nice. Yeah, if you are benchmarking something and In the example that you are benchmarking it, the compiler optimizes the heck out of it and removes the loop body. Are you really benchmarking the actual thing as if it was being executed in runtime in production? Not really. Improve finalizers. The new runtime add cleanup function is a finalization mechanism. This is one thing I was really excited about seeing earlier. It's more flexible, more efficient, less error prone than set finalizer. Add cleanup attaches a cleanup function to an object that will run once the object is no longer reachable. However, unlike set finalizer, multiple cleanups may be attached to a single object. Cleanups may be attached to interior pointers. Cleanups do not generally cause leaks when objects form a cycle. Generally cause leaks. And cleanups do not delay the freeing of an object or an object it points to. New code should prefer add cleanup over set finalizer. Sweet. Weak pointers. The weak package. The new weak package provides weak pointers. Weak pointers are a low-level primitive provided to enable the creation of memory-efficient structures such as weak maps for associating values, canonical maps for anything not covered by the package unique, and various kinds of caches. For supporting these use cases, the release also provides runtime add cleanup and map hash comparable. Okay, what are weak pointers? So when you have a pointer to something, you are keeping a reference alive in memory. You have a reference to some memory, and as long as you have access to that reference, the garbage collector is not going to clean up that memory, because if you try to access that memory at some point in time and it's no longer there, you're going to have an error. You'll end up accessing corrupt memory and all sorts of fun stuff. So a weak pointer is essentially a pointer to a space in memory that if there are no other references to that space in memory, it does not prevent the garbage collector from cleaning up that memory. So when would this be useful? So they give you some examples here. The thing that first comes to mind for me is a form of a cache. So something that I'm caching values and I have to have a reference to the value because it's in the cache, but I don't necessarily have references, pointers to that value in my runtime. And if I don't have those pointers in my runtime, then my runtime code, everything else that's running, doesn't really know that that value exists anymore, and the cache is free to, free that value. But if I was using a conventional pointer, I would have a reference to that value because the cache would hold that reference. With the weak pointer, the cache does hold that reference, but that's a weak reference. It doesn't keep the data in memory alive. So I think there's actually some really interesting use cases. Do I think everyone's going to go out and use the weak package and start throwing weak pointers all over their code? Probably not. But if you're working with like caching or caches, this could be a really interesting use case for that. New crypto mlkem package implements more crypto algorithms. Excellent. Post quantum key exchange mechanism. That sounds fascinating. I might look into that. More crypto packages. SHA-3. Woohoo. Sure. FIPS 143 compliance. New set of mechanisms to facilitate FIPS 143 compliance. Go cryptographic module is a set of internal standard library packages that are transparently used to implement these approved algorithms. Applications require no changes to use the Go cryptographic module for approved algorithms. Cool. Synctest. Synctest run starts a group of Go routines in an isolated bubble. Within the bubble, time package functions operate on a fake clock. If you need to mess with the clock or run code that is clock-based, this seems like a really useful thing. Synctest wait. Functions wait for all Go routines in the current bubble to block. Makes sense. Some minor changes to the library. Archive now has the add FS implementations on both archive zip and archive tar. Now write a directory header for an empty directory. Cool. Bytes add several functions that work with iterators. So we've got line, split sequence, split after sequence, field sequence, field func sequence, crypto AES, crypto cipher. I'm going to skip over those. If you're particularly interested in those, you probably have been waiting for those to come out. So you probably already know about those. More crypto, more crypto, more crypto, tons of crypto. My goodness, it's crypto all the way down. Debug elf adds support for handling symbol versions in dynamic elf files, executable and linkable format files. The new file dynamic versions method returns a list of dynamic versions defined in the elf file. Dynamic version needs method returns a list of dynamic versions required by this elf file that are defined in other elf objects. Okay. Encoding, two new interfaces, text appender, binary appender, have been introduced to append the textual or binary representation of an object to a byte slice. These interfaces provide the same functionality as text marshaller and binary marshaller, but instead of having to allocate a new slice each time, they append the data directly to an existing slice. Sweet. More control over those slices. Encoding /JSON, when marshalling a struct field with the new omit 0 option, and the struct field tag will be omitted if the value is 0. Okay, so like omit empty, we have omit 0, which is nice. Otherwise, the value is 0 if it is the 0 value for its type. So it's not just omit 0, it's omitting the 0 value for its type. So I'm sure they have examples of this, but I'm pretty sure this would be so like a float being 0.0. Okay, that makes sense. Data structures that expose sequences using a pair of methods such as length and at now have a method that return iterators, allow you to simplify code such as this to this. That's nice. Information about hashing, slog updates, looks like minor stuff for slog, math, big math now implementing encoder text appender. Seed function, okay, calls to the deprecated top-level seed function no longer have any effect. To restore old behavior using this, you can set this off. For background, see this proposal. More math. Net config. So listen config now uses MP TCP by default in systems where it's supported. Currently only Linux. IP now implements encoding text appender interface. So it looks like a lot of things are focusing on supporting the text appender interface that they've added. Net HTTP transports limit on 1.xx informational responses received in response to a request has changed. It previously aborted a request and returned an error after receiving more than 5 1xx responses. It now returns an error if the total size of all 1xx responses exceeds the transport max response header bytes configuration setting. Okay. It seems like a good thing to be aware of. I don't know if it's going to cause many changes or not. In addition, when a request got a net HTTP trace client trace got 1xx response trace hook, there is now no limit on the total number of 1xx responses. The hook may be used to return an error to abort the request. Okay. Transport and server now have an HTTP2 field, which permits configuring HTTP2 protocol settings. Sweet. The new server protocols and transport protocol fields provide a simple way to configure what HTTP protocols a server or client use. Also seems really nice. The server and client may be configured to support unencrypted HTTP2 connections. URL now supports implements encoding binary appender interface. OS user on Windows current can be used in Windows Nano Server. I don't even know what that is. The implementation has been updated to avoid avoid using functions from the Net API 32 library, which is not available on Nano Server. On Windows, current lookup and lookup ID now support the following built-in service user accounts. On Windows, current has been made considerably faster when the current user is joined to a slow domain, which is the usual case for many corporate users. Okay. GOAUTH function is now deprecated in new code. To use the system path to locate the Go binary, use the go-env GOAUTH to find its GOAUTH. I didn't know there was actually a function for this, to be honest. I've always been using, for as long as I can remember, go-env GOAUTH. The strings package adds several functions that work with iterators. Lines, split sequence, we talked about that already. Sync, the implementation of sync map has been changed, improving performance, particularly for map modifications. We talked about that too. Those are the not weak maps. Swiss tables. Testing, there's a new t.context and b.context methods to return a context that's canceled after the test completes and before test function cleanup runs. Test changedir and benchmark changedir methods can be used to change the working directory for the duration of a test or benchmark. Templates now support range over func and range over int. Cool. ports. So as announced in the Go 123 release notes, Go 124 requires Linux kernel version 3.2 or later. Okay, yeah, nothing particularly shocking down here. Weak maps. So the weak package provides ways to safely go to latest. Okay. Package weak provides ways to safely reinforce memory weakly, that is without preventing its reclamation. So there's not much going on here. There's essentially a type that is a pointer, and you have access to make and a value function. So they have information here about what a weak pointer is and why you might want to use it. I would go through this if that's something that's interesting to you. But I think the key thing here is essentially that you can create a weak pointer from a pointer to some value of type T, and then value returns the original pointer used to create the weak pointer. It returns nil if the value pointed to the original was reclaimed by the garbage collector. If a weak pointer points to an object with a finalizer, then value will return nil as soon as the object's finalizer is queued for execution. So even if it hasn't been removed yet, but it is starting to be removed. Okay, that's Go 124. I've got some things in here I'm excited for. Hopefully you do too. I'd love to know what you're most excited about to see from Go 124, or maybe what you didn't see in Go 124 and you're hoping to see in 125 in the comments below. Thanks and have a great day.